Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sir Sheraz, and in today's lecture we are going to discuss about the applications of electronegativity. We have discussed the electronegativity and the methods for the measurement of electronegativity in details. If you have not watched that videos, then go and watch that videos first and then come to this video so you can have better idea about the applications of the electronegativity. So let's start the applications of the electronegativity. The first application of the electronegativity is the estimation of electronic distribution in a molecule. If we look at a molecule, a covalent bond, then we can predict the distribution of electrons in that bond by using the values of electronegativity. So on the basis of this distribution, we can predict the type of bond that is found between the two atoms. If we look here are given two examples, that is one bond is between silicon and hydrogen, the other bond is between carbon and hydrogen. So we would look at how the distribution of electron is different in both these bonds. If we look at the bond between the silicon and hydrogen, the hydrogen is bearing partial negative charge, whereas the silicon is bearing partial positive charge. But if we look at carbon to hydrogen bond, the hydrogen is bearing partial positive charge, whereas carbon is bearing partial negative charge. So what is the factor that is controlling the partial charges on hydrogen in both these bonds? So basically it's the electronegativity difference that can give us the idea. Look at here, the electronegativity of silicon is 1.9, whereas the electronegativity of hydrogen is 2.1. So here hydrogen is more electronegative as compared to the silicon, so it would draw electron density towards its. That's why the hydrogen is bearing negative charge in the silicon to hydrogen bond. If we look at the carbon to hydrogen bond, the carbon is having more electronegativity as compared to that of the hydrogen with electronegativity of 2.5. So it would draw the electron density towards itself, and that's why the carbon is bearing negative charge as compared to that of hydrogen in the carbon to hydrogen bond. So we can predict the distribution of electron between two atoms, and based upon that distribution we can know the type of bond that is found between two atoms. Generally it is said that if the electronegativity difference between two atoms is less than 1.7, the bond is covalent bond, and if the electronegativity difference is more than 1.7, the bond is regarded as the ionic bond. The second application is the direction of reaction. We can predict the direction of reaction by using the electronegativity values. So how the electronegativity difference helps us to know about the direction of reaction. So basically it is assumed that a reaction in which a bond is going to be found between the most electronegative and the least electronegative atom, the reaction would move in the forward direction. As you can see here that hydrogen iodide is reacting with the chlorine. Whether or not the reaction would move in the forward direction can be understood from the values of the electronegativity. Here hydrogen is bonded with the iodine, and here the hydrogen is bonded with the chlorine. Since the electronegativity of chlorine is greater than that of the iodine, so this reaction is preferred to move in the forward direction. Why? Because most electronegative element is bonding with the most electropositive or least electronegative element, so this reaction is more preferred to move in the forward direction. If we draw the direction in the reverse, this reaction is not going to be take place in the reverse direction, because in this direction the most electropositive and the most electronegative element are separating from each other. Third application is the measure of enthalpy change. We can measure an idea of the enthalpy changes occurring during a reaction by using the values of the electronegativity. If the electronegativity difference is small between two atoms, the enthalpy of formation of that compound would be small and a weaker interaction would be formed. Look at here, the enthalpy of formation of the pH3 and NCl3 are compared. The enthalpy of formation of pH3 is plus 5.4 kilojoule per mole, whereas the enthalpy of formation of NCl3 is plus 232 kilojoule per mole. You can see here that there is a marked difference between the enthalpy changes of both these compounds. Why this is happening? Because the electronegativity difference between the phosphorus and hydrogen is small as compared to that of the electronegativity difference between the nitrogen and chlorine. So large electronegativity difference is leading to the very high values of the enthalpy changes. So we can say that NCl3 is a much stable compound as compared to that of the PH3. The next application is the properties of the molecules. So we can have an idea about the certain properties of the compound by using the values of the electronegativity. Mentioned here is that we can have an idea about the acidity of certain molecules by using the values of the electronegativity. Here are compared 4 covalent molecules and we are going to compare the acidity or the acidic character of these molecules. So if we look at the order, CH4 is the least acidic, followed by the NH3, H2O, HF. So HF is the most acidic compound in this series, whereas CH4 is the least. Why this is happening? Because the electronegativity difference between the carbon and hydrogen is least as compared to that of the electronegativity difference between the hydrogen and fluorine. So large electronegative difference is causing the most acidic protons, and the most acidic protons are leading to a large value of the acidity. So CH4 is least acidic, whereas HF is the most acidic compound. The next application is the estimation of the ionic character in a covalent bond. No covalent bond is 100% covalent. There is some ionic character that is present within a bond. So in order to have an idea about the percentage ionic character present in a molecule or present in a bond, we use the values of the electronegativity. And the values of electronegativity and the percentage ionic character gives us an idea about the covalent nature and the ionic nature of a certain bond. And you can look at here that fractional ionic character of a bond is given by the 0.16 Xa minus Xb plus 0.35 Xa minus Xb whole square. So what are Xa, Xb? Xa and Xb are the electronegativity values of the two different bonded atoms. Next is the bond length prediction. We can use the values of the electronegativity difference in order to determine the bond lengths of the certain molecules. Here is given the Shoemaker-Stevenson relationship. This relationship is used to predict or calculate the values of the bond lengths of certain covalent molecules, and you can look at here that it's equal to the Ra plus Rb. Ra, Rb are the covalent radii of the two bonded atoms, and Xa, Xb are the electronegativities respectively. So electronegativity values are also involved in prediction of the bond length Rab. So Rab is the bond length of the bond between A and B atom. Next application is the color of salts. We can use the values of the percentage ionic character present in a bond in order to determine the colors of certain salts. If the percentage of ionic character is less than 20, the salt would be colored, and if the percentage is more than 20, the salt would be colorless. Last application is the nomenclature of the binary compound. What are binary compounds? Basically, binary compounds are the compounds that are having atoms of the two elements. So in order to give the names to certain binary compounds, we use the values of the electronegativity. And it's supposed that a binary compound is the derivative of the more electronegative element. We are having a compound that is ICl. Can we write it as CLI? No. If we write it as ICl, the name would be iodine chloride. So this compound is considered here the derivative of chlorine. That's why it is called iodine chloride. And if we write in this manner CLI, then it would be named as the chlorine iodide. So which formula is correct? This one, ICl, because it's regarding the Cl as the parent and iodine is considered as the substituent. And in this form, CLI, the iodine is considered as the parent. So this is not a right formula. And the name is also iodine chloride is a right name, chlorine iodide is not a correct name. So this was all about the applications of the electronegativity. If you have any questions related to this video, you can post your questions in the comment section. We will meet in the next video. Till then, Allah Hafiz.